Hi everybody. A block diagram is often used by setting up a control system. But how can we set up a block diagram when we have a differential equation? What is the approach? Well, that's the topic of this video. Let's start off with a first order differential equation. It's a first order differential equation because the highest derivative is the power of 1. There's no higher derivative in this differential equation. So this is a standard differential equation of a first order system, which is equal to a time constant tau, which equals r times c in my example over here, times the derivative of the output, y is the output, plus the output signal y, which equals the input signal x. There are two ways how we can set up a block diagram. The first approach is by using only differentiators, and the second approach uses only integrators. So let's start off with the first approach, using only differentiators. And when we are using that approach, we are putting y to the left side of my mathematical equation and putting all the other terms to the right side of the equation. So this term is put to the right side of the equation, and then we get y equals minus rc times dy dt plus x. So y equals minus rc times dy dt, so the derivative of y, because it is put to the right side of the equation, plus x. And now we can make this into a block diagram by starting off with the input signal x and then working from right to left. So we have the input signal x, we have the output signal y. We take the derivative of y, multiply this by rc, and then subtract this complete expression. We subtract that from the input signal x, and that yields our output signal y. So that's expressed over here. Again, we have our output signal, our input signal x over here, and we have our output signal y to the right side of my block diagram. We take the derivative of y, which is expressed over here. We multiply it by rc, and we subtract x and the output signal of this expression. And then I have my new output signal y. So that's the first approach. A more common used approach is by using only integrators, and that is because the way computers are doing integrating instead of differentiating. So in that approach, where we only use integrators, we do the other way around. We put the highest derivative of my differential equation to the left side, and we put all the other parts to the right side of the equation. So in that case, we get rc times dy dt equals minus y plus x. So we can also say dy dt is minus y plus x divided by rc. And that is expressed over here. Dy dt is minus y plus x, this part of the expression, divided by rc. So multiplied with 1 over rc. And when we want to calculate y again, we have to integrate this differentiation, because integrating and differentiating are more or less inverse mathematical operations. So we get the integral of 1 over rc times minus y plus x. And because rc are constants, we can put that in front of the integration. So we can say y equals 1 over rc times the integral of minus y plus x. Now let's generate a block diagram out of this expression. So we start off with the input signal and then work from right to left. So we start off with the input signal x. We subtract the output signal y of this signal. Then we integrate the result, and we multiply that result with 1 over rc. So let's do it. So for the input signal, we have that put to the left side of my block diagram. We have y, the output signal, at the right side of my block diagram. We subtract y from x, so x minus y is over here. Then we take the integral of that part, x minus y, so that's the integral operation, and we multiply that by 1 over rc. Notice that there should be brackets over here. So that is another approach and a commonly used approach for generating a block diagram out of a first order differential equation. But that's an easy one. So let's look to a second order differential equation. In this situation, we have a second order differential equation which says that a times the second order derivative of y plus b times the derivative of y plus c times y equals x. And the first block diagram uses only differentiators. So what we are going to do is we put all the parts except of y to the right side of the equation. So we get c times y is x minus a times the double derivative of y minus b times the derivative of y. So x minus a times d squared y dt squared minus b times dy dt, and that equals c times y. So how do we get c? Well, by multiplying that complete expression by 1 over c. So here it is, my block diagram. So I have x over here, which is my input signal. We have the output signal y, and what we are doing is we put this to the left side of the equation. So we get x minus this part, which is the double derivative of y. First a derivative and again a derivative, which equals a second derivative. We multiply that by a, and we subtract that by that minus of x. We also have to take into account this part of the equation, which is the derivative of y, which is expressed over here, times b, which is expressed over here, and we subtract that again from x. And then we have c times y. So to get y, we have to multiply this complete result by 1 over c, and then we get y. So this is the realization of a second order differential equation when using only differentiators. Now let's look at the approach in which we only use integrators. Well, then I put the highest derivative of my differential equation to the left side of the equation and put all the other parts to the right side of the equation. And then we get a times the derivative, the second derivative of y, so a times d squared y dt squared, is equal to x minus c times y, put that to the right side of the equation, minus b times dy dt. So minus b times dy dt. This is a double derivative, so a second order derivative. How do we come to y? By integrating it and integrating it again. So first let's do one integration step. So integrate the left side of the equation, and that yields a times dy dt. Remember, integration and differentiation are more opposite or inverse mathematical operations. So one derivative vanishes when using an integrator. But when we integrate the left side of the equation, we have to integrate the right side of the equation too. So we get x minus c times y minus b times the derivative of y, and we have to integrate that complete right part. So it's the integral of x minus c times y minus b times, well, again, derivative and integration are more or less inverse mathematical operations, so we get b times y over here. So we get, again, the integral of x minus c times y minus b times the integral of a differentiation, so we get b times y. And that is equal to a times dy dt. So how do we get y? Well, again, by integrating this part of the equation, so also by integrating that part of the equation and then dividing everything by a. So we take the complete integration of this part of the equation, the right side of my equation, which is this part over here, and then we divide everything by a. Now let's see how we do that in a block diagram. Again, we start with the input signal and then we work from right to left. So the input signal, the expression with the input signal, and then do the other stuff. So x is my input signal, y is the output signal. So we start off with the input signal, which says that we have x, and we subtract from x c times y. X, We have y, multiply it by c, and we subtract that from x. And then we have this expression, x minus c times y. And that's the signal over here. Then we have to take the integral out of this expression. And that is this mathematical operation over here. So now we have realized this part of my equation. Now we have to subtract from this signal, we have to subtract b times y. So y times b with a minus because of the subtraction, which yields the signal over here, which is equal to this complete expression. Now we have to take the integral out of that signal. Well, that is this signal. And we have to multiply everything by 1 over a, which is the last step over here. So we've seen that there are two ways of realizing a block diagram out of a differential equation, by using only differentiators or by using only integrators. And the option with the integrators is more commonly used. Thank you for watching and see you at the next video.